Okay, so this is going to focus just a little bit of practice on reading and interpreting a phase change diagram, and also how to make one for the lab part. So this is actually the back of your target tracker. So if you wanted to turn to that, I'm just going to give you a couple quick point outs for this thing. So on your phase change diagram, you should see a couple of those points that we saw in the notes. Remember, this area here is going to be where freezing or melting can occur. It's just depending on if we're adding or taking away heat energy. And then this section here is where it could either be boiling or it could be condensing. Again, just depending on if we're adding or taking away heat energy. The states of matter, remember down here, go back to your notes, you'll see that this is just solid. You could have solid and liquid in this green section. This is just liquid here. And then you could have liquid and gas in the red section. And then over here it would just be gas. So that should help you for reading and understanding a phase change graph, and you should be able to answer those questions. Go back to your notes if you need help, or the textbook. Another thing I want to look at is you're supposed to go back and actually get your phase change lab target tracker from what we did last week and didn't have time to finish. So you should have on your lab, get it up here, this was the data that you collected from the boiling. So we started with the ice melting, water boiling. This was your data. You're going to use this to actually make a graph here, and I want to give you a little bit of assistance with this. So remember that your graph, you're going to be graphing what happened here. So this is your phase change graph. You're going to be putting the time down here on the x-axis, and the time was in minutes. And you're going to be putting the temperature on the y in degrees Celsius. So I'm just going to make a theoretical one here. You're going to actually plot your data. So the temperature in degrees Celsius, I think we can all say we started at 0 and it probably went up to 100. So let me think about scaling this here. I'm going to just do every other is 10 degrees. There's 20, 30, 40, 50, 60, 70, 80. That was not a wise move on my part, so you might want to scale it slightly differently or just have it go up like I did. So again, I'm making up theoretical data here. Theoretically, from 0 to 20 minutes being over here, we probably saw for the first couple minutes the data was hovering between 0 and maybe 3-4 degrees Celsius, depending on where the thermometer was. So I'm just going to make some points here that show it might have been increasing a little bit. Then eventually all the ice melted, and this is when we probably saw our temperature going up 10 degrees, 25 degrees, 35 degrees. I'm just making up some points here. 50 here. And then we're way up here, right? And then at the end of the thing, we started to see the temperatures nominalize right around 100 or so degrees. So if we went ahead and put that all together and made our graph, notice how if we were just, this isn't a scatter plot, we're actually making a line graph, so we're connecting the dots more or less. That you should see something that shows a little bit of those plateaus. Here was where melting was occurring. Here was where the boiling was happening. And in between, we had this high rate of heat exchange where it was liquid only, whereas down here we had solid and liquid, and up here you had liquid and gas occurring. So hopefully this helps you just a little bit about making your graph. You would also want to make another one here. Notice this is just going to be more of a sketch for the lauric acid part. So you started at a higher temperature and then ended at a lower temperature. So this one doesn't have to be perfectly plotted points, but at least a decent sketch to show you. And this time you would have a negative slope instead of a positive one.